So my name is Prasad. I think I'm audible, right? Okay, so thank you all, ISHRAE, ASHRAE and other members who have come over here. So for the next 30 minutes, I'll continue from where my colleague Venkat just spoke. So for the next 30 minutes, I'll speak to you about artificial intelligence and how it's changing the world and how it's changing the world for Vertiv and for all of you here and how it's going to change the realm of possibilities of what we are seeing right now today in the market. Okay. So how many of you here know a little bit about AI? Have read a little bit about AI? And how many of you want to know more about AI? So after 30 minutes, you want to know more about AI, okay? So that's a lot of show of hands. AI is not a new subject, okay? AI is not a new subject. The subject is at least, it's the first start of AI in university textbooks is in the year 1950s, okay, 1958. So it's a subject that's something like 70, 75 years old. But then it's gained a lot of prominence in the recent past, okay? So there's a lot of, it's a very busy chart, but I explain to you what it's all about. So AI has got into prominence. Which do you think is the first smartphone? Which company made the first smartphone?
Apple.
Pardon?
BlackBerry.
BlackBerry, okay? Okay, that was not smart, and it's buttons, right? With all that kind of jazzy, you can touch on the screen and touch screen phones. Which one did it? Apple. Okay, that's what everybody thinks. But actually there were smartphones where you can actually touch and do things before Apple also. But with Apple iPhone, sometime in 2005, 2006 time frame, so with Apple iPhone, smartphones became very popular. Okay, so they are kind of innovators. It is not that they invented it, but they got the technology to something like it's become so ubiquitous today, right? Smartphones have become like it's like everybody has one in their pockets. So similarly, there's something called ChatGPT. So ChatGPT is what brought AI to the forefront. How many of you here have tried ChatGPT? Okay, very less number of hands. ChatGPT was introduced by a company called OpenAI that works on NVIDIA DG100 chips behind. And this company launched ChatGPT for normal users in November 2022. So it is different from what you normally Google, right? What does Google do? Google goes and searches things for you in milliseconds and brings it to your screen. But what ChatGPT does is it can actually, it's closest to human thinking in terms of. So whatever ChatGPT gives you is actually generates. It generates content for you. It can understand your tone. It can understand what you are intending to. So it can mimic human intelligence, and it can actually create content for you, and that's why it's called generative AI. So AI as a subject has been there for long, whether it is neural networking, whether it is robotics, whether it is machine learning, and all that. AI has been there. So for example, you go to the airport today. How many of you use Digi Yatra? You don't need anything, right? Just go there, show your iris, and you are in. You don't have to wait for security check and all that. So that's all image processing and all that has been there, and all those technologies are quite being used in the modern day because there's a lot of computing power behind which can do everything in milliseconds. So ChatGPT is what is known as generative AI, and it generates content. So whatever content that you get on internet when you use ChatGPT, so please go to computers. It's available on everybody's computer here. It's available on everybody's phone here. Microsoft Bing. If you see Microsoft Bing is integrated with ChatGPT. This is a free version of it. ChatGPT 4 is also enabled on certain phones. You can ask questions. Suppose you want to go for a particular public speech and you want to give a speech on the recent elections and what happened to the Prime Minister. You want to give a 5-minute speech on that. Ask ChatGPT to give you a 5-minute speech. You want a 10-minute speech on that. It will give you a 10-minute speech. You want to give it if you want to give it a content like the Prime Minister's party, you can tell that, like a BJP person. But if you want content different from a BJP's party, but from the ruling Tamil Nadu Chief Minister's standpoint, you can ask that, and ChatGPT will give you that kind of content. So that's the kind of intelligence that is built into AI, and this is going to be the next revolution. And this is going to be the next revolution for a lot of reasons, and it is going to be for all people here. The ISHRAE, ASHRAE, Vertiv, all people in the electrical industry. It is going to change the game for us. And that's what we will talk about in the next 20-25 minutes. See, I've already covered a lot about this. AI is a broad discipline with many subfields and different model types. So there's large language model, there's natural language processing, there is deep learning, there is neural networks, so it encompasses everything. So ChatGPT is the Western version of it. Indian Institute of Technology in Bombay is doing what is known as Bharat GPT. Okay, so Bharat GPT is understanding all the Indian content on the internet and also putting more content so that answers get the Indian flavor and Indian tone in the answers. A lot of things that you see today are with the Western tone. So Bharat GPT is an initiative by the Prime Minister's office right now to get Indian content for Indian users and in multiple Indian languages. So this is the definition of AI by ChatGPT. It's a simulation of human intelligence in machines that are programmed to think and learn like humans. So it's constantly learning. As it gets new content, it's constantly learning so that it can fine-tune the model and it can give you closest to what we expect. Okay, so that's what all generative AI is, again a field of AI where the difference is it generates new content. Whereas what the normal AI is, it studies existing content. But generative AI goes a step further and generates content. So it's one of the most hottest topic today. And whatever you see on the slide here, okay? So on the left side, you'll see somebody with a lens and all that. With the hat, this guy is the discoverer or the detective. And the second lady there is an artist. And these images are created with generative AI. None of these two gentlemen or that lady there exist. So we had given prompts. We said this is the way we want a detective to look like. Somebody who's around 60 plus years old with a lens in the hand, with a hat. He should be fairly looking, he should have a white beard and all that. This content, whatever you see on these slides that I'm showing, is all generative AI content. And there is nobody in human existence on this planet Earth with those two faces. So that's the power of generative AI. It can generate content for you based on your prompt, and that is what's called prompt engineering. So you tell it something, it will create tokens, and you pass the tokens. There is a lot of work that goes behind billions of nodes, billions of analysis in terms of what is generated and what is actually discovered, and then they bring it to the minimum in terms of what's known as Nash equilibrium, wherein the difference between what is generated and what was originally intended is minimum, and then it throws the output to you. So it is not perfect. That's why when you use ChatGPT and Copilot, Microsoft and all that, you will see it's not perfect, but it's getting to be very, 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 very perfect. So it's using to generate content, and outputs of the model are natural language. It can be videos, it can be text, it can be audios. Somebody would have seen, if you have been following, there's a lot of deep fake videos that are being generated today, right? Prime Minister Narendra Modi doing Garba. He never danced. And similarly was West Bengal Chief Minister Mamata Banerjee also. They never danced actually, but you can generate content. So that's the beauty of this, and it can be used in good ways and bad ways. So that's a different discussion about ethical use of AI and all that. So any AI model needs to be trained. Okay, so for training is the first part of it. A lot of what's happening right now is AI models being trained, and everybody is trying to make their own AI models. The ChatGPT is the AI model of this company called OpenAI. Kritrim is the AI model of this company called Ola that's creating an Indian AI model. Bharat GPT is an AI model that's being created. It's a large language model. It's created by IIT Bombay, IIT Chennai. It's an Indian AI innovation. So there's a lot of training that goes into it, which means there's a lot of data points already, and you need to constantly learn about it, billions of nodes, interactions, and tokens. That's the training part of the model, and then is the inferencing part of it, which means you ask for something, it gives you the output, so that's the inferencing part of it. So in this again, these are all very, very energy intensive processes about which I'll talk a little later on in the next slides as to how is it helping, how is it creating load for the environment, and how is it helping companies like Vertiv in its business? Because we are seeing that rack loads of traditional workloads are completely changing today. And it's going to the next level. It's not just 2 times, 3 times, but it is something like 20 times of what we are seeing right now. So training models and inference models. So training models can afford some kind of power shortage, power interruption in between, because it's training. But an inference model cannot. So when you ask, you go to the airport and then you look at the camera for DG Yatra and the whole thing comes down because there's a power infrastructure problem behind. That will be a very, very disappointing experience, right? So the inferencing model cannot afford to fail. It needs to continuously run. So we need to keep it humming. That's what our tag word also is. We need to keep the power and the cooling absolutely on behind all these data centers that are processing the data, so that you get that seamless, bumpless, continuous experience when you're working on the inference and when you're asking for information. So AI is as I said, the ChatGPT moment, or the Apple iPhone moment of AI was ChatGPT introduction in November 2022. So $40 billion is the value of AI business in 2022, but it's exponentially growing to something like $1.3 trillion in 2032. So even that is underestimated, is what I heard recently. As Vertiv, as Venkat was showing you earlier, there are these 3 big top trends that Vertiv is looking at. One is about data center growth and power usage, and AI is a big thing in that. So one of the agencies called Del Oro says that 22% of data center workloads in the year by 2026 should be AI workloads. But then there are other agencies with whom we work, and some of them say approximately 50% of workloads that we see in the data centers in the next 3 to 4 years is going to be AI workloads. So I'll come up with one slide about that. So 50% of workloads in the near future, it could be 2 years, it could be 3 years. Venkat was saying India is a bit slow, but India is catching up in a big way. India is catching up in a big way. One of our customers is already having AI as a service platform in their data centers in Panvel near Mumbai, wherein they're giving AI as a service. Because nobody wants to invest, because these servers of NVIDIA and these servers are extremely expensive. One single server could be upwards of $300,000 to $400,000, which means 2 to 3 crores. So no CIO or a CFO is going to give you $300,000 just like that. So probably people want to try out on AI as a service from cloud operators, and then get used to that, see the benefits of that, and they would start investing in on-prem. Okay, so what we are seeing is it's a $1.3 trillion business is what we are seeing is AI is going to be in the next 2032 is what they say. I predict it's going to be faster than that. So it's a real opportunity. It's a real opportunity, and do you have the right infrastructure? So this is something like a tsunami that's coming in front of us. It's there in front of us. Are you getting ready for that? And that is where Vertiv plays, and that's where we can help our customers retrofit their existing workloads and their infrastructure in the data centers to be ready for AI. So AI is like all-encompassing today. It's cutting across verticals. So it's in, whether it's in technology, so a lot of coding, a lot of people whom not Satyam today, Infosys, Cognizant and Microsoft and all these, the TCS and everybody employed, at least 30% of them are staring at a job loss, because a lot of what human beings can be done will be done by robo-assistants, will be done by AI coding machines. So technology companies, consumer companies for conversion rate increase. Okay, so it's a matter of privacy invasion, but it is real today. So all companies, FMCG companies, etc., want to sell more products to you. So you look at a smartphone. If it's enabled, it can see even your iris, the way you're looking at it and all that, and it can generate content for you. It can show you ads on the screen, and you start buying more products. So consumer companies, for example, I was just recently reading about Air India and the Taj group of hotels with the Tata company. Both of them have actually started using. So if you make a complaint about Air India or give a feedback to Air India either on their SMS system or an email or on Instagram or on Facebook, all that big data is collected and they're making decisions out of that, how to improve the customer experience. So consumer companies, B2C companies are using it in a big way. Pharmaceutical research, so genomics and all those kind of, the new vaccines and life-threatening diseases research, that's all, it will be much more accelerated right now with AI systems. Okay, financial institutions. Financial institutions are the first, I would say, early adopters of AI, because they don't have raw material, they don't have work in progress, they don't have compressors, they don't have heat exchangers. Their input is bits and bytes money, cryptocurrencies and all that kind of, even the stocks and derivatives and everything. So financial institutions are in a big way already. Some of the large banks in the world, some of the Indian banks also, whether it is ICICI Bank or HDFC Bank, today when you talk to them on the chat, it is actually not a human being behind, it's a chat bot behind. That's probably the first level of using AI and machine learning, but there are much more better things coming up right now. So financial institutions, entertainment industry, insurance companies wants to know your credit rating. So when you talk to an insurance company today, they'll ask you Aadhaar card, PAN card, this card, that card. No card is required now. From all your interactions on the web, on the social media, the company can figure out how credit worthy are you. And you can imagine an insurance company or a finance company trying to give you a loan premium and all that, or even giving you loan EMIs and rates of interest based on your actual data. They don't need to ask you, they don't need to ask the date of birth. It's all there on the cloud and they can figure out everything. And they will use all the data for making the user experience better for each one of us. So as I said before, JP Morgan, American Express, Bloomberg, Deutsche Bank, Commonwealth Bank, some of the Indian banks, HDFC Bank, ICICI Bank, and some of the Indian branches of the foreign banks, they're already using financial institutions, are some of the early adopters of artificial intelligence. So what exactly is this? So how does it help us? This is all about the AI part. How does it help us? It's because earlier all data processing in computers traditionally was in CPUs. Okay? But then it's all moving to what is known as GPUs and accelerators, graphic processing units. Graphic processing units has been there all along for the last 30-40 years, even when I was a child probably. But then they were used for gaming machines, and that's what NVIDIA was famous for. So these processors, they are not processors which can produce which can actually process a lot of sequential data, but they can do parallel processing. So it's like the simplest example for that is like CPU is like a Ferrari, but GPU is like a 10,000 small trucks or auto rickshaws or whatever it is. So they all parallelly process data. So it's each one of them maybe cannot handle a large volume of data, but each one handles a small amount of data and they churn out much faster. So when this is done, what they also see is that the heat density and the power density requirement in chips is growing exponentially. So GPUs, can somebody tell me this is new Blackwell 200, B200 GPU that was announced by Jensen Huang, who is NVIDIA's CEO. He just launched the Blackwell GB200 GPU. Can somebody just guess how many number of transistors? How many number of transistors are there on one single chip of GB200? Just a guess. How many number of transistors could be there? Guess, any number. 1 to infinite is the numbers we right? Just guess. A million, okay, good guess. Anybody else?
3 billion.
3 million, okay, not bad. Come on,
1 trillion.
1 trillion. Oh, who is that? Oh, you should do Jensen Huang's job. Right now it's 208 billion, okay? 208 billion transistors on one single chip, which is actually two-sided. So it is like the limit of what even physicists can think. Nobody would have ever thought. The earlier version of this chip, which is around 3 years old, had just 40 billion. I'm talking about billion, okay, not million. 208 billion transistors on one single chip. So you can imagine, that's what I said about this 10,000 numbers of trucks and auto rickshaw, an example, right? So it's billions of transistors and everything, complete circuitry, but the whole thing generates a lot of heat. A lot of heat. It's like one Blackwell GPU, GB200, it is like 1200 watts. Okay, it's like 1.2 kilowatt. Sorry, it's like 1.2 megawatt, it's 1200 kilowatts. It's like 1200, it's like 1.2. So that's the kind of, I think it's something totally wrong. It's 1200 kilowatts. Okay, that's 1200 watts. That's the kind of each chip. 100 kilowatt.
1.2.
1.2 kilowatt.
Yes, 1.2 kilowatt. It's just one chip. So in one server there are 8 of them. So just imagine the level of heat load that one chip can generate. Okay? And the earlier version was just 700 watts. So 700 watts to 1.2 kilowatt is just one chip. And in one server there are multiple GPUs and each one of them. So there are new challenges. Just one chip. So like your iron box is like 750 watts. This is 1.2 kilowatt, one single chip. So that's the level of heat load and IT load and power load that's required per chip in the new modern servers. And it's all about parallel operations. So it's like 1.2 kilowatt, hundreds of them work together at the same time. You can imagine the rack load density. Each rack load, which is originally something like 3 to 5 kilowatt, because each chip is now 1.2 kilowatt, it's going to be hundreds of kilowatts. So we have actually done a project right now for an Indian customer, which is from the government of India, high performance computing. So I'm not telling the name right now. And the requirement was 36 kilowatts. And we thought, wow, it's tough. Right now they've come with a new requirement. They want 8 racks, each with 80 kilowatt. Each rack with 80 kilowatt. So that's the kind of heat density and power density that will be required in the upcoming future. So what we see right now today, because people think it's not there yet, Venkat was rightly saying it's slow in India, but it's fast catching up, okay? So what we are seeing right now in India or in the world today, 75% of the load is within 20 kilowatt per rack. 75% of the load is like 20 kilowatt per rack. But with each chip of 1.2 kilowatt that's coming up, which is Blackwell, which we've not got a single chip in India right now, except some IITs have already started getting it. So with each rack getting to upwards of 100 kilowatt per rack, you can imagine. So what they're saying is only 3% of the global load right now is more than 70 kilowatts. But then the whole thing is trending towards like 56% of all the 59 are all saying that rapidly or slowly they're all going to see high density racks in the near future. Okay, so again, so this is like, okay, so what we're saying is in 2070, this was the average low density per rack. These are all the big hyperscalers. They were something like 9 kilowatt per rack, but they're going from 9, they're already at 9, so they're going to upwards of 25 kilowatt per rack, okay? So that's 3x. But what about other guys? The co-location players who are something like 3 to 4 kilowatt per rack, they will grow at 5.3x times the rack load. And what about other guys, enterprises, on-prem enterprises, which are again in the range of 3 to 4 kilowatts, they will all be growing at something like 5x. And this is real. And this is a big challenge, but also a big opportunity for all of us in the industry. So higher rack density, as I said before, it brings in a lot of challenges. It will be wider and heavy duty racks. So what is the average kind of a load that today what we see in the rack spaces? It's like 1.5, 1400, 1500 kgs per rack. Right, Nitin? Yeah. 1400, 1500 kgs per rack. But then we already have in our Columbus office in the United States where we have got a demo center, a solution center. We've already displayed a rack which can take upwards of 5000 kgs, 5-ton racks. Racks that normally, height of the rack is something like 48U, 42U and all that. But racks with heights of 52Us and upwards is going to be something very normal, because finally at the end of it, it's physics, right? So you need to have wider racks, taller racks. Okay? And then there is IT gear. I talked about IT gear a server of NVIDIA could be upwards of the Blackwell chips and all that. Now they have come to this new server platform, the accelerator, which they're going to come in 2026. They just announced that in Taiwan around 3 days ago, in a developers conference. So Jensen Huang, the CEO of NVIDIA, who just announced the GB200, the Blackwell 200, which is a 1200 watts chip, 1.2 kilowatt chip. Just 2 months ago, he's talking about an accelerator, and that's called the Rubin platform. Okay, and then there is competition. So there is NVIDIA, who's eating all the cake right now, with all the kind of share prices of NVIDIA growing upwards of $1,200 per stock. Okay, there are only 4 companies on this planet which have got more than a 2 trillion valuation. So one is Microsoft, the other one is Alphabet, and the third one today is NVIDIA. Okay, so NVIDIA is in the list of the 4 companies. And there's a 5th company, which is Saudi Aramco, which is in the oil business. But there are only 5 companies on this planet universe who are more than $2 trillion market cap, and NVIDIA is one among them. And all this in the last 6 months. All this in the last 6 months. And this, so IT gear, each NVIDIA server is upwards of $300,000 to $400,000, 2 to 3 crores. Okay, and each one is quite heavy. So these are not like the olden days of servers. So each one is quite heavy. So you can't have more than 6 or 7 servers in one rack, which means one rack's valuation just of the servers is something like 20 crores. That's one rack's value. So this is what's happening. Higher amperage power distribution, because when there's higher IT load requirement, there's higher amperage power distribution. There is profile of GPU loads. All of them will come up at the same time when it's processing. So you need to have higher amperage of power loads, higher capacity power systems, and then sustainability targets, because we also need to look at the earth and the environment, power grid constraints. So the complete powertrain and the complete thermal chain over the next few years will undergo a sea change. So big opportunity for all in the OEMs, for all ODMs and all the consultants here. And for all the end users, it's a challenge, so we are here to help you. So emerging cooling technology options. So air cooling was an option all along, but today rack loads are going upwards of 50 kilowatts. Up to 50 kilowatts you can manage with the hybrid of air cooling and water cooling. But beyond that, you have to essentially go for water cooling. So things are changing today, and short turnaround times, because you've got a rack which is down for some reason. It's a 20 crore rack. You can't wait for 2 days for an engineer to come and to solve issues, right? So you need to ensure that shorter turnaround times. There's a lot of load on service fraternity and all that. But luckily again, as Vertiv, we have around 500 service engineers. So we are the biggest one in terms of our biggest USP is our service portfolio. We've been in this business for the last 30-35 plus years in this country and in India alone. So we've got 500 service engineers in India on our roll, plus through our partner and franchising network, we've got another 500. So we've got 1,000 engineers across the country in the service portfolio. So shorter turnaround times, costly IT gears, service complexity, and as Venkat was talking about, everybody's a plumber. Earlier the IT and facility were separated. There was a thick wall between IT and facility. They wouldn't talk to each other. But today you're injecting liquid up to the chip, up to the server. So IT and facility, that particular wall that was there before is now, it is blurred. It's come closer. So that's all the big changes that AI it's not just the AI and that part of it, it's also changing on the infra side. So I want to talk a little bit about Vertiv and what we do in the AI space. So NVIDIA is this company which is in the news right now with all these GPUs, and they've got this Rubin is the next platform that's coming up in 2026. They've already announced it. It's the next platform. It's different because it's got a memory stack which was earlier 8, now it's going to be 12. So, and in terms of one Rubin platform, I was reading it's 2,800 watts. Is one Rubin platform, 2 CPUs joined put together. That's coming 2026. And along with NVIDIA, there's other companies like AMD and Intel. So AMD's CEO, who's again a celebrity now, her name is Lisa Su. She's also announced, so they're coming up with their version of the platform which is equal to NVIDIA, because it's a space that NVIDIA's and Intel's and everybody in the world and AMD's want to compete with. And Vertiv is in close partnership with Intel, NVIDIA, and with AMD and all the chip manufacturers. Okay, so there's a program called the the cooler chips program. So there's a $40 million grant given by the Department of Energy in the United States. 2% of global power usage today is with data centers. And it can go up to 8 to 10% in the next coming 3 to 5 years. That's what they expect. So 10% of global power usage in data centers is going to put a huge load on the power requirement and the cooling requirement. So this means that we need to do something. So the Department of Energy instituted a grant of $10 million, $40 million, $5 million. There are 13 consortiums that competed for getting $40 million. Vertiv, NVIDIA, one of the national laboratories, Boyd, who is a cold plate manufacturer, 2 universities, Binghamton and Villanova, and Honeywell for the refrigerant and all that. So we have all come together, and Vertiv is the partner which is working to ensure that these Blackwell chips and the next generation chips can be cooled in a sustainable way. So NVIDIA introduced its flagship Blackwell platform in GTC, which is the Global Technology Conference in 2024, approximately 2 months ago. This is what they have shown as their reference design, and there is this particular unit in this which is called the coolant distribution unit. And this humble coolant distribution unit called the XDU1350 is owned by Vertiv. So it's on the reference NVIDIA design. So when you're working on projects with NVIDIA GPUs, when it comes to infrastructure, when it comes to cooling, think about Vertiv first, because we have a partnership with them, and we are a certified NVIDIA partner, and we are a certified NVIDIA partner, and we can give the solution. And this is on the reference design shown by the Vertiv, by the NVIDIA CEO Jensen Huang in the GTC 2024. That Vertiv solution is part of the NVIDIA reference design. So nobody would want to take a risk on one server is $300,000, $400,000, 2 to 3 to 4 crores, 5 servers in a rack, 20 crores one rack. Would you want to take a risk on taking some cooling solution from somebody who's not worked with NVIDIA? They've got proven solutions, and this solution called the seed for the XDU 1350. It's a 1.2 megawatt XDU. We are right now working with them on the next generation of a 2.2 megawatt XDU. So that's the relationship with which we work with NVIDIA, and this is all part of the Cooler Chips program that we're currently doing with NVIDIA. Okay, so NVIDIA has a global, how much more time do we have, Diti?
I think more 5 minutes.
5 minutes more? Okay.
We have a video also.
Oh, we got a video. Okay, yeah, there's a video. Okay, so the NVIDIA is now part of the, Vertiv is now part of the NVIDIA partnership network. NVIDIA partnership network across the world, and there are other partners. Some of the names are known to you: Dell, HP, Deloitte, Accenture, Lenovo, Supermicro. These are all known names, and there are other names also. But Vertiv is also an NVIDIA partner right now. So when you invest in NVIDIA GPUs, when you invest in the next generation AI technologies, it's Vertiv that is there to help you do the physical infrastructure for both power, cooling, and IP management solutions. So this is what one of the industry analysts have said, Barron's. So NVIDIA CEO has talked about a partnership on public domain, and I'll show you the video next. His name is Jensen Huang, who is now a celebrity now. His stock has grown from hardly a few dollars to $1,200. You can imagine the kind of money people would have made. So he's a global celebrity today. So he talks about the latest Blackwell CPUs, GPUs, and how Vertiv as a partner is helping them grow the ecosystem.
World is transitioning from general purpose to accelerated and AI computing. Compute density and therefore power density are increasing incredibly. Every aspect, from computing, networking, and software, are all groundbreaking computer science. The data center infrastructure is also incredibly complex. The most advanced cooling and power technologies are essential. Vertiv is the world leader. We've enjoyed a great partnership with Vertiv for many years, and our collaboration is growing in leaps and bounds. As every industry and region invest in building AI factories at enormous scales, our partnership with Vertiv is more important than ever. I want to congratulate Jordana and Vertiv on an extraordinary year. This is just the beginning of great things to come as we partner to put AI in the reach of every company and industry.
So Giordano, who we said in that, is Vertiv's global CEO, and Vertiv is also a rock star in the US stock markets. Vertiv was listed in the year 2020 on 1st of February at $8.50. $8.50, 2020, February 1st. How many years back? 4 years back. What is, other than Vertiv, yes, please. What is Vertiv stock price yesterday? Any guess? You can guess. $5, $10, $15, $20. Dollars, okay, not rupees. $100. Okay, great. So Vertiv, pardon?
You can answer in the morning. 1,000 increased.
1,000 times. Yeah, anyway, so Vertiv stock has gone up to $110 approximately. There's a 52-week high around the last week. I saw it yesterday, it's around $89 or $91 right now. So this AI boom has also helped Vertiv also grow its wealth for its shareholders. So that's why Giordano's name was talked about. So Vertiv is side by side working not with just NVIDIA, we're also working with other Intel HANA platform and other platforms of AMD and Lisa Su, the CEO of AMD and all that, because they're also coming with their, there is Rubin, there is Ryzen, which is the platform of AMD. They're also coming with 2026 GPUs and accelerators. So working with all of them so that we can give them solutions. So a little bit about low density means up to 10 kilowatt, which is currently the conventional, but medium density 10 to 25 kilowatt is catching up in a big way. And as workloads increase, rack density could go to high density, 25 to 80 kilowatt. And we are right now working with some Indian customers, names I can't tell them, but they are working for 80 kilowatt plus 100 kilowatt, 120 kilowatt per rack, which is extreme high density. Okay, and nobody wants to, everybody's invested in the last 5 years. So they want to retrofit, they want to upgrade, and that's where Vertiv comes to. So we help customers, we've got complete solutions when it comes to cooling, from perimeter cooling, row-based cooling, passive air door cooling. This is all the air cooling part of it, but there's a limit to air cooling, okay? So there's a limit to air cooling, and then we need to go to liquid cooling. So that's direct to chip and immersion cooling. You can actually dip your servers in a liquid and a dielectric non-conductive liquid, and then you can actually cool your servers. And we've done this with one of the largest Indian payment companies, payment app companies in one of the data centers in Bangalore. So we do all this starting from something like 10 kilowatt. We're already working with customers in India. In this range right now, we're working on projects wherein we will come to 80 kilowatt plus. Maybe in the next 6 to 10, 12 months time, we'll have installations in that region. So again, this is some of the companies who have used direct liquid cooling and air cool. So air cool is about cooling air and passing it. It's quite inefficient, but it's efficient up to something like 50 kilowatt per 45 kilowatt per rack. But more than that, you will definitely need to pass liquid. So you will need to pass liquid. It will go to the chip. It will cool the chip. It will take out the heat. It's something like sweat on the forehead. You can remove it. You can recirculate. That's what the CDU does. XTU 1350, which I showed. So some of these large companies like HP are said that they have served $2 million per year on approximately 10,000 servers just from air-cooled liquid cooling. And then it also helps in terms of 17 million pounds of carbon dioxide reduction overall, sustainability goals. So that we help customers help reduce their total cost of operations over the life cycle, help meet their sustainability goals, and reduce their cooling and power consumption requirements. So there are these big companies, Dell, NVIDIA, Dell, Lenovo, HP, and Supermicro, who make these servers. Not all the servers that you get in the market today can be liquid cooled. So there is air cooled servers, and then there are liquid cooled servers. Okay, so there are some add-ons that you can add to some of these boxes. So you can make them liquid cooled. Some of them you can actually immerse. None of these here are immersible type, but Dell does have such kind of servers also. So these are ones where you need pass the liquid up to the server, up to the chip, get the liquid, get the heat out. So future-proofing your data center investments, that is what Vertiv does. Your existing load, IT load, so we can add, it's an air-cooled rack right now in the range of 5 to 10 kilowatt per rack, but you want to go to 80 kilowatt per rack, 50 kilowatt per rack. You may not go in one go, but you need to go in a graded way. We help you add this air cooling unit. So this is what the current situation is right now. So we can add what is known as the CDU, which is what I talked about. It's made by a company called Coolterra, based out of the UK, and we bought this company. It's part of the Vertiv portfolio right now. So we can give you XDUs, which is right now 1.2 megawatts highest capacity, and then it will completely change the game. It will start passing liquid up to the chip. So we have this complete solution. So we also have what is known as RDHX, which is a rare door heat exchanger. That is again air cooling only, but it is closer to the rack, direct air right to the chip. So we have that. So we can retrofit. So it's not that I bought 42 U racks or 48 U racks and what do I do the investment? No problem. Vertiv is there. We can help you upgrade. Take it from 10 kilowatt to 40 kilowatt, 40 to 80, 80 to 120 over a period of time. So the investments also you can monetize the investment. That's what we are into. And of course, there's a lot of things which is in the rack which is not where we cannot pass the liquid. Like power distribution units, the switches, etc., are not right now liquid coolable. So there's a challenge. So they still need to be air cooled. So that's all the challenge that we're right now dealing with in the market. So when it comes to direct chip infrastructure, the advantage is that the water temperatures can also be elevated. So you don't need to pass 20 degree, 30 degree and all that. Your outlet direct water temperature can be 50 to 60 degree and your inlet can be 30 degrees. So you can elevate, and when you elevate the water temperature, which means you're directly saving energy, we've got solutions for that. So that's what this slide talks about. We'll help you to elevate the water temperature so it's much more efficient than air cooling. Of course, it requires investment, but over a period of time, you will actually monetize these investments. So you can operate the chillers at higher temperature and all that. It overall saves energy. So capturing savings on it requires new approach. It's not that whatever you've invested so far goes for a complete toss. No, we help you to in a graded way bring it from air cooling to hybrid of air and liquid cooling, and then completely liquid cooling if needed. So we are helping you address these challenges. So it's not just cooling alone. I've been talking about cooling alone because that's what the biggest in energy intensive process in the data center is. So we also have the complete powertrain. So starting from the grid to the chip, from chip to atmosphere, the complete powertrain, starting from transformer, the switch gears, the distribution units, the UPS, or it may not be even UPS. Today customers are talking about DC workloads. Okay, so the data center does not have UPS. It's a DC and battery, and we're also working with some Indian customers. High performance computing, no UPS, completely DC. Some of the large data centers, Amazon and Microsoft have already started using that. So there's no UPS, it's rectifiers and DC systems. So we are also into that. We also have a diesel portfolio. We also have other portfolio like battery and energy storage systems and bring your own battery and all of that. It's not just the cooling, we also address the power. And you can imagine 20 crore rack, would you want to put a 20,000 rupees local power distribution unit to give power to the server? Absolutely no. So there are very high-end PDUs, 63 amps, 83 amps, 100 amps power distribution unit, which Vertiv has got a company called Guys, which we have got 5 years ago. It's part of our portfolio. We can give you high amperage, intelligent, socket monitored, phase sequencing, power distribution units, and we can also help you manage the complete IT management of your of your installations. So powering up the computer room is now more complex. It's just not an electrician's job. It's an electrician's job, it's a plumber's job, and we are seeing that challenge. We help customers to overcome these challenges. So accelerated workloads and AI comes to play. The whole game is changing. So there is bus bar, high amperage bus bar, and also intelligent busway systems. So we have all of that. So we are seeing this challenge, and we help customers address these challenges and help you retrofit your existing on brownfield projects. Also help you design so that you can have installations which are ready for workloads upwards of 30, 40, 50, 100 kilowatt per rack. So that was my last slide on the deck. Thank you very much. I'm available just one more time for questions.
With that amount of energy, passion,